the panel session on infrastructure as a service. My name is Bob Kozdemba. I'm a principal architect in the public sector group with Red Hat. I live in Austin, Texas, but work in the government group and find my way back east here. Actually, as well as many other places in the country. But thanks for standing in, sitting in to our panel session here. We have three really great panelists that'll be hopefully engaging and entertaining you during the session here. And before we get started, I'll just give you an idea of kind of the way things will flow here. We have about 40 minutes, and what I'll do is I'll start off with some introductions for our panelists, and I'll start off with maybe one or two rounds of questions, so you folks can start thinking about your own questions. And then about halfway through the session, we'll open up the floor for questions and encourage good interaction with our panelists. And I just ask that we keep the questions focused on what these guys do best. I work for Red Hat. There's a lot of guys from Red Hat here, and we can answer any product questions out in the hallway. But let's keep the focus of the panel on the fine work that these guys have done. Sound good? So let me introduce our guests here. First, we have Hoot Thompson, and Hoot works for NASA and works in the high-performance computing area with cloud computing. So he'll have a very hands-on perspective on some of the challenges associated with that industry. And actually, we were talking before we got started. So my nickname is Kaz, and we have Hoot, and we have Wolf, and we have Jake. And I was thinking, after this, we should start a rock band.
But Hoot's my real name.
Hoot's your real name? Awesome. Good. You got that one. So, okay, so we have Hoot Thompson from NASA. On Hoot's left is Wolf Tomby, and Wolf is the Chief Technology Officer for the Customs and Border Protection, which is a Department of Homeland Security. And on Wolf's left, we have Chris from Chris Jacobson, who's a technologist from IBM in their federal group. So what we'll do is we'll get started with some guys can give you a little bit more about their background, but I figured I'd just start off with a quick intro. And my first question to kind of kick things off here is for Hoot. And since we're talking about infrastructure as a service, certainly OpenStack comes to mind, right? It's like the hottest thing out there right now. And what better person to give us a perspective on the history of OpenStack than someone from NASA? So Hoot, maybe you can kick things off and kind of give us an overview.
Sure. First of all, I want to get the disappointment out of the way. I am not an astronaut. That comes up every time. It would have been cool if I was an astronaut, because then I truly would have seen clouds from a different perspective. But nonetheless, I do work at NASA, and specifically I work out at the NASA Goddard Space Flight Center. In particular, the NCCS, which is the NASA Center for Climate Simulation. We run a large HPC cluster, 6,000 physical nodes, 40,000 cores, that kind of thing. And we run long-range climate simulation models. But the question had nothing to do with that. It goes back to the formation of OpenStack. So yes, some 3 years ago or so, NASA, mainly our West Coast branch, if you will, NASA Ames out at Mountain View, stood up with Rackspace and created this project called OpenStack. And we actually built a cloud that you may have read about called Nebula. Nebula existed in reality in two containers. There was a container dropped on Moffett Airfield, basically out there at NASA Ames, and we have a container out at Goddard right outside of our building. That's the good news. We stood it up, we got it operational, and I wasn't really in on the ground floor. I got in on the testing level. They basically had the piping in place, and they said, let's see if now we can create some use cases. And as you probably know, we didn't create those use cases. We did the testing. It had some functional issues. It had some performance issues. And NASA pretty much fell away from the whole OpenStack environment. We still have a container in our parking lot, but it's not running Nebula. I personally did a lot of benchmarking from an HPC perspective on Nebula, standing up a cluster in the cloud, seeing how it would perform on some of our types of codes. But that cloud was based on a 10 gig infrastructure, and we could take it offline. You don't do 10 gig and do HPC, you do InfiniBand. So on the good side, though, is we're now all about OpenStack some 4 years later. But we're taking a different perspective. We're building a grassroots cloud where we're bringing up VMs, bringing up small installations of OpenStack, get our customers, married to it, and then grow our cloud over the years to come. So we're building what we're calling a science cloud to be a number of things to a number of users at Goddard and hopefully NASA at large over the years.
Okay, very good. So that gives us a nice foundation to think about with regard to infrastructure as a service. So let's move up the stack a bit and take a higher level view, and maybe we'll ask Wolf about you're involved in standards and best practices with a number of agencies in the government, and what challenges does cloud computing present with that regard?
Well, I think CBP, a lot of other federal agencies are making the commitment to move to open standards support and open source wherever possible. The reasons for that are pretty obvious. We've got to move away from our legacy history, which was pretty typical for large organizations, where our systems were based on proprietary technologies, often tightly coupled together with other proprietary technologies, which are a very expensive proposition for us to operate and maintain. And we're moving towards more loose coupling of our systems based on standards and wherever possible open source. So huge cost savings for us as an agency. We're not alone. VA is doing the same thing. DoD is doing the same thing. So the move across the federal space is pretty consistent towards open standards and open source. In terms of cloud, that's critical. So you have the open cloud standards, and if we're going to be successful in being able to migrate two clouds and then transition from one cloud vendor to another cloud vendor, we have to have those open standards in place. If we don't, we're in serious trouble, and the cost of migrating could be prohibitively expensive, if not nearly impossible for us. So it's absolutely critical for us to have these kind of standards in place.
Great, thanks. And let's see, we'll get Jake started here. Maybe you can give us a perspective from the vendor side of things. You mentioned that you're involved with a project with ISR partner, working on a prototype to run your smart cloud environment.
Yep.
Comment on that?
Sure. Just want to mention first that OpenStack has proven to be a really great vehicle across industry for collaboration to deliver a great cloud computing capability. Key players are really coming together, allowing the pathway for innovation, interoperability, really providing value for the end clients. What we're doing, we've actually been working very closely with some of the DoD services, one particular in the intelligence, surveillance, reconnaissance arena, to both help, as we're reducing headcount to some very skilled folks that do these analytics around the world with some very important data sets coming off some very highly complex sensors, being able to both make sense of all that information and be able to collapse the processing time to something that's what we call actionable insight. In other words, you can do something with it other than understand the forensic context of what happened, hours and hours ago, maybe days ago, trying to bring it to within hours. So we've had some really great breakthroughs in an open environment. It's on a stack of equipment, this experiment called PureFlex that some of you may have heard about. I'm sure almost everybody knows about Blade Center, which really, I kind of think of Blade Center as the wonderful stack for the SOA era, and SOA is still wonderful and important. But as we look forward to the cloud era, PureFlex is kind of that integrated solution for virtualized compute, virtualized network, and virtualized storage, and then bringing that open management framework and that entry point for cloud. So what we've been successful with in this first phase of the POC, and right now in the second phase, we're introducing OpenStack. In the first phase, what we were doing is virtualizing some very powerful real-time analytic capabilities, bringing it in the virtual machine, analysts to be able to provision that capability to the data, wherever that data is. And we've had some very dramatic results. The other thing that was really dramatic about it was integration collapse and integration time. A lot of this high performance capabilities, oftentimes you're dealing with complexities of job schedulers, and oftentimes you have to customize them to the specific use case that you're trying to tackle. And what we were able to do is essentially bring a COTS solution, abstract away that job scheduling, and bring a known unknown integrator in with their analytics. And actually within the on this POC, within the scope of 1 week, we were able to integrate their third-party application into this real-time analytics, provision it in a virtual machine environment, and then get some results by the end of the week, which is really unheard of. But so we had, I'd say by the end of the week, it was 16x improvement over the government's baseline capability, and 6 weeks later, 60x improvement, and we briefed that out to the Pentagon and got sponsorship for that program.
Sounds great. So Hoop, back to you. So when we talk to customers about moving to the cloud, quite often the topic of is the workload right for the cloud? In HPC, you know about traditional data centers, a lot of bare metal, a lot of diskless servers and things. What challenges does cloud computing present to HPC specifically?
Well, I guess to go back to partial my answer before, a cluster, typically a high-performance computing cluster, if you look at the top 500, it's all predominantly InfiniBand interconnected nodes for a cluster. And what InfiniBand does over a 10 gig E or that type of technology, very low latency, microseconds, very high bandwidth. And that's what you need in an HPC cluster, high communication at low latency between all the nodes. So how do you stand that up in a cloud that's typically built out of 10 gig E? That Nebula testing I referred to says you don't. We've also done a lot of testing. As we moved away from Nebula, our own OpenStack cloud for a while, we moved to Amazon like a lot of people. So I benchmark a lot of these codes in Amazon space as well. Amazon has the same issue. How do you run an HPC in that kind of cloud? So with Red Hat, actually, I've been doing a lot of work over the last 2 years in virtualized InfiniBand. So being able to bring IB, InfiniBand, up to the VMs and get that same low latency and same high bandwidth. And we're proving it. We did a talk at Red Hat Summit back in June on that topic, and we showed that we can get near bare metal speeds with a VM interconnected cluster. So now we, in fact, are working with Red Hat to try to push some of those constructs into the OpenStack code tree so that you'll be able to stand up an HPC cloud like you can any other service in a cloud environment.
Impressive, and I know you've done some work with our engineers at Red Hat Summit. Can
Yes.
you comment on this?
Well, there's some tuners up in Boston that have been, we got Dave here locally that's helped me with the basic OpenStack infrastructure. But guys, Shaq, I don't even know his whole name. Shaq and Mark Wagner in particular up in Boston are just dynamite tuning guys. If you got just your basic RHEL environment, you just want to tune it, they can help you. They can help you with node-to-node stuff. It's an excellent support team that you have. And one of the other things we're going to learn how to, the other thing we need to be able to do in a cloud environment is be able to stand up a cluster and tear it down rapidly, which is different than standing up a single instance running a server that does some job. You have to stand up 100, 200, 300 nodes. They have to have common namespace. They have to be interconnected, and you have to be able to run a job over those hundreds of nodes. And that's another challenge for HPC in the cloud.
Very good. How about you, Wolf? What are some of the pitfalls encountered?
Yeah, I think there's a couple things. One is kind of a buyer beware. So cloud is a very hyped term right now. A lot of people and organizations are advertising cloud capabilities or software as a service, infrastructure as a service. And you have to really be cautious. Not all clouds, not all cloud services are alike. In fact, some of the cloud services are not cloud services at all. They're managed services. Sometimes I would argue not well managed, but they're managed services, not cloud services. And if you get into one of those capabilities, you really have to understand that you're not going to see the cost benefits or the cost returns that you expect. And you're probably going to have problems you wouldn't expect, like outages and other things. So you really have to know the backbone and the background of your cloud provider and your cloud service provider. And that's incredibly important. Another thing is to have a really good contract in place. So contracts for cloud services are very different than anything we've traditionally done in the federal government. So if you don't have acquisition people who are experienced in this, I highly recommend you have your acquisition people reach out to somebody else in another agency who's done this. You need really strong clauses about migrating to the cloud, what happens in the cloud. For example, we have very strong monitoring requirements within any cloud provider's environment. Why do we do that? because we have to be able to show that if there's an outage, the outage is not on our end, or if it is, we need to know that. But if the outage is in the cloud, we have to be able to pinpoint and prove that, especially in terms of enforcing our SLAs with the cloud providers. Now, not all cloud providers want to provide that capability. I say if they don't, move on to another cloud provider. It's just that simple. So there are a lot of learning lessons that we're learning, but we're learning them kind of along with industry. And so there's a lot of opportunity like here to share those experiences and give a leg up in terms of lessons learned.
Okay, very good, thank you. I think before we turn over to the audience, we'll ask Jake about the Federal Innovation Center that IBM
Yeah, just a couple weeks. IBM unveiled the Federal Cloud Innovation Center just a few blocks away from here. It really, it's another shot in the arm at collaboration with academia, industry, and the government, understanding those key mission capability gaps that need to be collapsed, and that collapsing total cost of ownership, reducing risk, improving security, and that comes through collaboration with your key customers, and that's what we're doing there. And it builds on a legacy that IBM has in the open arena. Certainly back, you all remember the days of e-business and e-commerce. I mean, going back into the 90s, IBM has really embraced the open movement for quite some time. 99, IBM invested $1 billion. A lot of folks may not realize this, but invested $1 billion in Linux, committed 350 developers. If you Google just about anything IBM, you're going to find that IBMers are everywhere. They're running blogs. They're in the open space. They're making major contributions. That's part of the IBM culture. The same is holding true now with this Federal Center, Cloud Innovation Center that's been opened up. We've, I'd say in spring, we dedicated 250 developers to OpenStack. We committed an additional 500 folks just a couple weeks ago to this whole, to the Federal Cloud Innovation Center, advancing cloud projects, open cloud projects. We committed 400 over the summer working those cloud projects. So what we're really hoping to do through the center, through our investment, is building up the brainware, the collective brainware, if you will. It was interesting. General Colin Powell, he spoke at the unveiling, and he said something that I won't forget. He said, if we have the willingness to change our way of thinking, we can achieve great things. He said, you can change the software, you can change the hardware, but you can't change the brainware. And so, you know, we'll have to work on it together.
Thank you. Okay, who has the first question? Up here in the front. If you could just state your name. And
John Brinkman with the Federal Judiciary.
Hey, John.
Right now, OpenStack is less a product than a toolkit. Okay? And in order to produce a product, various vendors put together the pieces that are missing and call it a distro, distribution, etc. How do you deal with this potential for divergence where you end up with, again, parts that are clearly open source, some of which are, you know, open source but different, and as well as closed source?
Who wants to take the question? But certainly everyone can respond. So
I'll try a couple answers, and nod if any of them hit. We run into that, and we have been running into OpenStack versus provided paid-for software. Pick on GPFS, which is IBM's global parallel file system. Our cluster currently runs SUSE. We're looking at Red Hat. And to run GPFS, you have to have a standard distro where GPFS won't run. It only runs on SUSE, it only runs on Red Hat. It won't run on Ubuntu, Debian, da-da-da-da. So you have to marry the two and work within the environment that you have. Doing the same thing with, I stood up a Hadoop infrastructure last year. And guess what? We're running Cloudera on top of it, which is sort of the Red Hat of the Hadoop infrastructure. So yeah, and part of the advantage we have too in working this is we are a 24/7 shop, but we're not a 6-9s. We do climate, okay? It's important, but it's climate data. We're not running a shop that if it goes down, really bad things happen. People get upset. So we're in a position where we can be more adventuresome, is where I'm going with this, more cowboys, more on the edge in terms of being comfortable living with the OpenStack and some of the volatility, plus blending in the third-party paid-for software. That make sense?
Yeah, I think it's a transitional process, and the one thing, it's not so much about the technology, it's more about the culture, and it's the culture within our industry partner, culture within the agents itself. So there's still a belief that if it's not really expensive, it's not good enough for our mission, because our mission is protecting America, protecting the borders, facilitating international trades. The economy is dependent on us. And so there's that thought that if it's open source and it's free, it can't be stable enough, it can't be good enough. So it's an educational process. It's bringing things in, demonstrating that they work, proving that they can handle our capacity and our capabilities, and it just takes time. It takes time for the culture to change to where it's just totally embracing open source. I think with the millennials, as the new generation workforce, they were brought up on open source capabilities, and we're expecting, I think it's 46% of the workforce by 2020 will be millennials. I think they're going to have a very strong voice pushing us more aggressively towards open capabilities and maintaining those open capabilities.
And from an IBM perspective, that's our bread and butter. We are an open source company. However, we're bringing much more than open source to the table. You have that continuum of completely open, roll your own. There's an awful lot of behind the scenes effort that goes into getting it right. And at the other end, you have that closed proprietary. It might be rock solid, might be trusted, but the doors to innovation is closed. Licensing costs are high. And we're striking that middle balance, which is, again, it's a lot of investment in brainware. We're trying to get security right all the time, get it to scale, trying to reduce TCO. Those are the key constraints that we're trying to do with everything open. Hadoop, that you brought up, is a perfect example. Here we are today, we made the move, one time was platform-centric, interoperability. We went net-centric interoperability. Now we're at data centricity, and what we're trying to do is get the data layer. I mean, the explosion in data is unstructured. We still have, RDBMSs are still relevant, but explosion is unstructured. You got to get that data layer ubiquitous and open to all forms of analytics on top of it. Big data analytics, and it's coming from innovation from everywhere. So you have to kind of get that right. So Hadoop, taking the example of Hadoop, the move we made on Hadoop, is certainly, it always is, you can download the Hadoop core, the open Hadoop core. But what we've done is we're always moving. We're on those boards, we're on those panels, we're in the open body, so we know what the roadmap is. IT bodies, so we know what the roadmap is, so we can anticipate and invest to add those additional layers. So what we're doing is securing Hadoop. Scalable. We're making it a lot more user-friendly so that they're wizards, for big sheets or what have you, Excel-like metaphors for really being able to exploit all that mass unstructured data. So those are the kind of things that we're doing, just an example of Hadoop, but we're doing across the board with pretty much anything in IT, any class of IT you can think of, we're following that pattern.
Question over here on the left.
Security as far as the open source, is there like a peer group that reviews the code? Is there anything official in place? You get a lot of well, it's open source, anybody can stick anything in there.
Yeah, I think that's a great question because that comes up all the time. And I would argue that actually open source is more secure than a lot of the proprietary. And why is that? Well, one, we can see the code. So we can easily scan the code, and we do. We can look for backdoors. We can look for Trojans. It's there. You can't do that with a proprietary capability. You have to rely on the vendor that provided you doing that for you. Do it real well. Sometimes they don't. But let's look at last year with zero-day exploits. The open source community came together and was actually issuing patches to resolve some of the zero-day exploits in 2 to 3 days, while our proprietary vendors take weeks to months to issue the same patch. So I would argue that open source actually gives us a better security profile, but you have to kind of get that knowledge out to people because there is this concept that it's inherently insecure.
Sort of an interesting sidebar. I was asked that same question as part of an interview. We just made a switch from our job scheduler being a proprietary version to open source Slurm, which is not rolled up by a third party like Red Hat. So we have to go through a vetting process of that code. But just like Wolf said, we have that luxury. What's interesting, I found, not only with NASA, but other customers, if you put a red hat in front of open source, it's automatically trusted. You don't have to go through the vetting process. And you scratch your head, it's still open source. But that's another nice thing that a red hat kind of infrastructure provides you, is you don't have to go through every line. You still can, but you don't have to. At least that's the way our security department treats it.
No, I agree with you.
Gentleman here.
Goes through, we overpurchase the hardware because we don't know what's going to happen in the future. With all that hardware sitting there, and we see IBM and HP embrace that, this question is more towards, do you envision taking that existing hardware and dropping OpenStack on it to utilize your current infrastructure?
Yes. Yeah, so it has. I don't want to get into vendors, but we have done that with one of our hardware vendors, and specifically took their product back to bare metal and have installed Red Hat and JBoss and other capabilities on it. So that's definitely a possibility. I think the other thing we have is we have an RFP about to hit the streets for our next generation core infrastructure. And in that RFP, we're specifically saying two things. One, it has to be based on integration purely on open standards and open source capabilities. And we have 44 tests we're going to run in order to verify that that's true. And we're telling the vendors up front what those tests are and how we're going to run them and why. We've gone to great lengths to define what we mean by open standards, open source, and open architecture. So it's very clear to the vendors who want to compete on that, what we're talking about. And we've actually, for the first time, said that this infrastructure can be provided to the government in two ways. It can be provided as infrastructure as a service, or it can be provided as a pre-built appliance-based infrastructure that we expect the vendor to provide at least level 2 support and maintenance on, which basically, again, gives us platform as a service. So that's what we're doing. We're pushing that out as our next generation infrastructure buy, and we have great hopes for it.
Yes. Let me get my cloud leader back here.
So yeah, version 2.3 originally that just came out supports both Intel and Power, and you can run it straight up on our P-series or our Power-based PureFlex.
Thanks for the assist, Chip. This is Chip McClellan, who's IBM's federal leader for cloud here today.
I'm still wrestling with having the budget to overbuy hardware.
Yeah.
I'm sorry. I sort of missed the answers to the questions.
In the back, we had a question there.
Yeah, there is, and it's actually called FedRAMP, and it's been operated now for several years by GSA, and it is a certification to a moderate CNA level. Now, for us in CBP, a lot of our data is law enforcement or trade specific, so we require high. But we can take those controls from the FedRAMP medium and just apply the additional controls. We don't have to start from the ground up again. So yeah, the FedRAMP program is for clouds that want to offer services to any federal agency.
Still open for questions. How about this side? One? I was thinking, we got one more up in the front here.
Within the OpenStack community, there's a healthy discussion as to the nature of the APIs matching or not matching commercial cloud providers. And the problem, of course, is the commercial cloud providers, for certain well-defined cases, are going to have a wonderful cost point. Comments?
I'll just mention, with the acquisition of SoftLayer recently, I don't know if you've heard about IBM's acquisition of SoftLayer, but at their heart, their infrastructure management service or system was actually the initial baseline or reference architecture, if you will, that was provided to Rackspace in the early goings of the OpenStack framework. SoftLayer is adding to IBM 21,000 new cloud customers, and that architecture is supporting all the cloud OpenStack APIs as well as EC2 APIs. We're bringing with that acquisition, we're bringing in 13 additional data centers. 2 of them look like they'll be added to our 3 existing federal data centers, so we'll have 5 federal data centers. But yeah, that is a major area of focus. Again, is the APIs, the methods, constantly adding to. Right now, I think it's 3,000 and counting methods with that architecture, but also migrating that to more and more to an open kind of converted architecture.
Yeah, and from my perspective, we have a lot of legacy capability that has proprietary APIs. We're going to move away from those. We are committed as an agency to open standards and open source, and we're going to be mandating that as a clear requirement. So do we have some proprietary APIs today? Of course we do. But going forward, as I mentioned with this RFP for our common infrastructure, it's mandating open. And if you can't pass the tests, you fail. It's just that simple. So we're dead serious about the move to open standards and open source.
Anyone else? Still have a few more minutes. We have one gentleman in the bridge.
What the failover capability we got? How well is that? Like one data center to another. OpenStack gives it.
Well, yeah, I think clearly you can have clustering and failover capabilities with open source tools today. We're actually doing that with our core infrastructure for open messaging. And because our messaging, we're into the billions of messages a day, and it's law enforcement and trade sensitive, that has to be highly available. So we're absolutely actually looking at clustering and using other technologies to point us to our 2 other data centers for global failover as well as internal local failover.
I guess from our perspective, we perhaps make a distinction between a typical VM environment and a cloud. I think our cloud is going to be more of the temporal nature, where instances are spun up, jobs are done, and they're spun back down. So from a reliability and a failover perspective, it doesn't come into play as often. If we need the HA capability and a more always-on kind of capability, I suspect we'll be standing that up in a Rev environment, vice a ROS environment. So if that plays to your situation or not, I don't know. Because yeah, VMs, we view them as a replacement for a server, not somebody trying to run something new or different that may have temporary usage.
Yeah, and I mentioned a little bit earlier the PureFlex architecture, that's positioning for the, for the cloud era of infrastructure as a service. But the whole software-defined environment, whether that's the compute tier, networking, or storage tier, the high availability COOP, DRP kind of capabilities, essentially certainly delivered through that cloud architecture, that virtualized architecture.
I'm sure there's probably some newbies out there that are just getting started with cloud computing in infrastructure as a service. So if I'm brand new to this stuff, where do I start? What workloads do I think about moving to the cloud? What challenges can I expect?
I tell you, to me, and this is not Red Hat, to just get a sense of what a cloud is and how it works and what to do with it, Amazon will give you a free account. Go out there and play. And you can bring up a Linux instance, you can bring up a Windows instance, you can run some jobs, you can SSH into it, you can bring up a GUI, do whatever you want. Get to understand what a cloud capability is, and you can do it on your own or at work if you get the approval, but get a sense of what you're talking about before you launch off and start buying hardware and software.
And to echo that, there's also, if you want to go with an open cloud model, same thing. You can go to IBM's cloud, what's the softlayer.com, and just pull it down, play with it. As they were talking about in the last session with the GitHub, you have to dive into it, and you really start kind of getting those muscle groups working in the cloud.
Yeah, I think I'd add to that from a lessons learned perspective is don't pick something mission critical. as your first attempt to get into the cloud.
The best thing that's been said so far.
Exactly, because you're going to have problems. It's not something you want to have problems with. So pick something that's fairly straightforward. You have to actually understand your application really well. Not all applications are necessarily suited for a cloud, or will even run effectively in a cloud, depending on how they were created. So you have to be aware of what the application is. I would say pick something that's a fairly low-hanging fruit that's not critical. Move that first. Run all your performance tests, your availability tests. Really hammer it hard to make sure it can do what you need before you start moving up the ladder in terms of importance of your applications.
And just to play off what Jake says, and I've said this in other forums, Red Hat documentation is actually some of the best documentation you'll find. So if you're at Venturesome and want to cut a DVD and have a server, you can stand up a ROS cloud on a one-node system using their documentation, their how-tos, and get a pretty good feel of what it takes to actually build one yourself.
Question? Go ahead.
How have you handled the training or skill set component of moving to a cloud architecture? Specifically, software-defined networking. Typically, you have people that are very familiar with Cisco or Juniper or a certain hardware set, and now you're telling them, oh yeah, the network, it's running in there somewhere. You can't go in and actually look at a port anymore. You can't console into the switch or the router and get something done. So there's a kind of a disconnect between the two worlds as far as, you have the old and the new.
Yes. My turn to say yes. You probably have your answers, both of you. It is a different world, and I've been going back to Dave. That is probably the biggest challenge in working the cloud, is getting the networking right, getting that infrastructure right. From a training, we're at the geek end of the stick, and we're just diving in and training ourselves. I imagine these gentlemen have more formalized processes, or are looking at a more formalized process.
Well, and I would just throw in that a lot of, and part of this innovation center speaks to it. An awful lot of what I have seen firsthand is with our proof of concepts with our federal customers and some of the systems integrators, is when they actually get on to the system and they're, for example, we're virtualizing various storage architecture. It doesn't matter what brand it is. We're virtualizing, single pane of glass for being able to deal with your storage tier. Again, as you're talking about the software-defined networking, where now the administrators are able to essentially provision network, design that network layer and the server play and the asset play in the network. What we're finding is it is dramatically simplifying. I mean, what we're seeing is the administrators are picking up these skills very fast. It's drag and drop kind of a metaphor. We seem to get very quick traction. Now, as far as formal training programs, I don't know. Again, from IBM, we have all sorts of red books and training materials that you can get it just by going in DeveloperWorks, or pretty much if you Google into anything IBM on an area that you want to get trained on, you're going to be able to get access to it. And other partners is the same thing, that are kind of playing in that arena with that migration to these virtualized tiers of IT assets. So, I mean, I would offer that up certainly from IBM. You'd be able to get access to that. An awful lot of the open components are also accessible, through that pathway. And again, if I would get the word out that if there is any kind of roadblock in terms of training, certainly companies like IBM and others in the open parts of the industry would be able to kind of collapse those barriers to entry for training.
Yeah, so from my perspective, there's three very disruptive things occurring at the same time for us in IT. One is mobility, which is incredibly disruptive from both an IT perspective and the mission perspective, in a good way of empowering the mission. The other is cloud, which we're talking about. And the third is the move towards agility and getting rid of some of our very long-term waterfall processes. All of those have cultural aspects for an IT shop. So as I move towards adopting infrastructure as a service, do I need somebody who rack and stacks boxes as their job description and installs OS on it? Probably not. But do I need somebody who can actually now be a service manager? Yes. Can that person be retrained to be a service manager? Very possibly. I need scrum masters. Can that person be retrained to be a scrum coach or a scrum master? So while the change can be very intimidating and even cause a lot of fear on the part of employees? Are they going to have a role in this new organization that's cloud and mobility and agile based? I would argue they certainly can, but they have to show a willingness to change. If they want to hold on tightly to that legacy methodology, then it becomes far more problematic because we are moving and we're moving away from those legacy capabilities.
We have time for one more question. And all the way in the back.
What lessons have you learned in bringing the application development side of your teams into the methods necessary to really do cloud-aware apps as opposed to more traditional design patterns?
Go ahead. We actually started in 2007 by launching our very first enterprise technical architecture. That was intended to be a several-year initiative, even though we didn't tell people that. And it was intended to break what was occurring at the time, which again was typical for large organizations. Every application had its own infrastructure. That infrastructure was often different than another application by the same application group. Different versions of OS, different versions of the database, sometimes entirely different OSs and databases, all running standalone. And we wanted to break that model and actually get people moving towards common infrastructure and common coding practices. So we implemented the first generation technical architecture, which set out high-level principles, like we're going to use layers in terms of creating applications. We're going to separate the presentation layer from the business logic layer. I mean, this is typical stuff today. It was culture shock for us because we hadn't been doing anything like that before. The second generation, we actually came out with coding standards, and that was culture shock. We had never done that before. The third generation, our engineering group did a great job of coming out with a common development infrastructure called United. So we actually put scripts in that United environment, so when people check in their code, we're now scanning for compliance with our third generation technical architecture. So it takes time to make those kind of changes across a large organization. You can't do it all at once. The culture shock is just too severe. So we actually are now at the point where we hope to be back in 2007, and we're just about on schedule. But it's been incremental change, and it's been a lot of mentoring. So I actually have a team that goes out to the application shops and does hand-holding and mentoring. Every time we come out with something new, we came out with SOA. We had to go teach them what that meant from an application development perspective. I mentioned we were moving to layered application architectures. One of our development shops actually created their own layers. We thought that was interesting, but not what we intended, so we had to clarify the guidance and go out and do more mentoring. People want to do the right thing, but you have to teach them. It's not enough to publish an architecture and give them a book. You have to go out and actually do transformation support with them and get them on board, and you just have to do that. Otherwise, you're not going to move.
Just by way of contrast, we actually have the opposite problem. Most of our code is decades almost old scientific climate code. So we basically want our scientists not knowing they're in a cloud because their code can't be changing because we don't want all of a sudden shift the temperature belt because we've moved code into a cloud environment. So these are dusty Fortran decks that have just moved through time, and now we're just trying to move that same code to a cloud environment and get the same results. So there's not a lot of new development going on in our space. So it's sort of an interesting, different look.
Yeah, well, just real quick, we're almost.
As a follow-up on that, please. How do you get your tech people, your architects, and your developers used to working in the new structure with program people, the question you just raised, who are not quite as agile or not quite as cloud-focused? And I think from a program side, there's a lot of need there.
Well, at least in our organization, you got to find the one guy that wants to be the Maverick, and we've got him. We got this guy that runs these multi-day nature runs, and he's willing to learn the new thing and take the chance, and then we create the tug of everybody else coming along once we got the one guy showing that it can be done.
Yeah, absolutely agree. Yeah, find your people who are trying to do it and are starting, and praise them, highlight them publicly, give them awards. You'll be surprised how quickly other people are like, well, I want to do that too. Yeah, so positive reinforcement's a good thing.
Yeah, very good. I'm told our time is up, so can we have a hand for our panelists here? Good job, guys. Enjoy the rest of the symposium.